Chapter 7, Lesson 5, Scale Drawings, Day 2. Again, where our state standard specifically talks about being able to find that missing measure. Many other things with scale drawings, like we saw yesterday, scale factor, things we're going to see again today. But the big takeaway is finding a missing measurement. Like here on this one, being able to set this up and find that other dimension, whether on the model or on the scale drawing. That's what we're looking for, the real thing. So when we look at this, again, we're looking for that word scale. So put a box around that. In the word problem, that's our big thing. We're looking for the scale. So this earthworm that Mr. Lehman has a scale model of has a scale of 1 inch to 8 centimeters, or 1 to 8. So we write that as a fraction. On the scale, that's where we start. So everyone say scale. When we look at that scale, that's what we need. Remind yourself that that 1 stands for inch and the 8 stands for centimeter. From there, they're going to give us another dimension, either in the picture off to the side or in the word problem, and then we have to figure out where that 1 goes, where that 0.125 or 125 thousandths of an inch. Notice that 0.125 has the label inch with it, so we need to match that here. Inches is on top. Inches with the 1, so the 0.125 needs to go on the top. That's the only way we're going to get that correct answer. Put an X on the bottom, and then we switch to the cross product, where we're then going to take 1 times X, we get that 1X equal to, and multiply that on out. Carefully with the calculator, and the more decimals we get, watch their placement. So that also comes out to be 1. Interesting. But that's what it is with the math. So we're set to go. But now again, remember to follow your X. Since the X is on the bottom, it's going to have that same label as the 8. It's going to have that label on the bottom of centimeters. So the model is 1 centimeter wide on that worm. That's the big takeaway, finding that missing measurement. That's what we want to be able to do all the time. Of course, we're going to be given some things like this, again, where we have to go and measure. So it says refer to the map below, or yesterday's assignment it said go to example 1 and then find the distance. So again, with our rulers, we would measure. Today we don't have to do any measuring, but coming all the way down here, this one is switched to an inch ruler. So make sure the 0 of your ruler starts here on Orlando. Most rulers, if they're the paper ones I have in class, the 0's at the end. So that can make it tricky to get an accurate reading as the rulers get beat up and bent and shortened in all reality. But some of the rulers have a 0 that starts here. So wherever your 0 is, make sure it's on the spot that you want it on, and then line it up. So we're going to line it all the way up here. And on inches is what we're supposed to use here. So we're measuring in inches, and that's where we get to know all these little marks here. Well, since it says to the nearest ½ an inch, we can make this pretty easy. When you measure it out, it's right about there. So when we're looking at that guy, we're going to be looking at, well, here's ½ an inch. The longest thing between the two numbers, between the inches, is ½ an inch. And then the next one, that's the next longest, is halfway between a half. So as you're looking at that, here's that ½ inch, and then halfway between it is here, and ½ of a half, well, that's a 1/4. So we could get really specific here, but in all reality, it should come out to be something really nice and even. So we're going to go right here and say that that's 1.25, or 1 1/4. So that measurement is 1.25 of an inch. That's, again, 1 1/4 an inch. So we're going to take that guy and use it. Cool. And again, sometimes we can do this math mentally and rock it out, but all the time it's going to work is by finding that scale. Everybody say scale. I don't know if you said scale, but you should say scale because we're going to use this guy right here as our scale. So notice we've got it set up here. Half, or 0.5, so you can write it out as 0.5 over 17. And that's where we start with because that's our scale. That equals the other number that we need. So if you're running out of room, you can find room down here below. We'll just bring that on in. So we've got that again, half 0.5 over 17, and you can write down those labels off to the side to help you out, especially me since I can't see it up there. So half an inch represented 17 miles. And then we had that other number, 1.25 inches. So we're going to set that up here and set that equal 1.25 inches because that's the distance on the map. Here's the distance on the map referring back to each other. And we don't know how much it is in real life. We don't know how many miles it is. So we take and do the cross product, get a lovely half x or 0.5x. And that is equal to 17 times 1.25, and we cross our fingers and hope that comes out nicely. Not too bad, but it comes out to be 21.25. And then you need to solve this equation. So divide each side by that 0.5, by that half, because we want to get rid of that half in front. So all we have left is the x. Divide this side by 0.5. Type that into a calculator, get our answer, about 42.5. Map is slightly off there, but it does work out. And again, here we go. Find that variable. If it's on the bottom, what label did the 17 have? It had that miles, so our answer is going to have the label of miles as well. Put a box around it. Now again, you may have to measure, maybe not. This is the big takeaway here, is just being able to set up a proportion and find that missing measurement. That is the big goal with scale drawings. Again, when we talk about this scale factor, when we see scale factor, it just means the same label. So write that on in quick as a note to yourself, that scale factor means the same label. That's a silly question, but I'm still going to say it here in the video and in class. I would say, are inches and feet, are those guys the same? So when we look right here, do they have the same label? No, they do not. So when we look at the inches and the feet, we want them both to have the same label. Whichever one's the smallest, make them both that. Since it's inch, almost always the first one on the left or the top is going to be the smallest. Make feet into inches. To do that, we have to remind ourselves that there are 12 inches in 1 foot. So because of that, we're just going to take that 3 feet times 12 for every one of those inches, every one of those feet. So we get 36 inches, which is great. That equals your 1 inch, or you could have that set up as a ratio as well. That should say the word inch there. And now from there, do they have the same label? When we say yes, they do, that is where we then write our final answer out with just the numbers. So 1 equals 36, or most likely what you would rather see is 1 to 36. The scale factor of 1 to 36, meaning 1 inch to 36 inches is how that scale factor works. So when you're looking at it, that's what we have. Again, seeing those, whether you get a picture or not, this one you don't actually have to measure. It just says what is the actual area for the hallway. So we're looking right here at this guy in the hallway. And then we need to find a scale, which if it's not down here in the picture anywhere, then we're going to go looking in the word problem where it says, here's our scale. Half an inch equals 3 feet. So we're going to be using that. But before I get there, let's see here. Writing it on in. Half is 0.5. So half to 3, so that's an inch and feet. And now it says, what are the actual area of the hallway? So we'll have to find out the actual dimensions. So first, how long is it? to figure that out, we got to go up here and see that here is 2 inches. And then this area here is 4 inches. So we want to know what that total length is. That is 6. So we're going to plug that on in where the inches is at. Got that cross product ready to go. So half x equals 18. Great. And we shall divide both sides by half so that we find x equals 36. And that label is feet. Hooray! But no, don't box it up. I wanted to know what the actual area was. Now we got to go again. And we have to go through and find out what is this dimension over here, how wide it is. That's given to us here at 1/2 inch. So if you don't catch it right away, you set up the proportion. 1/2 over 3 equals 0.5 over x. And we do that cross product there. And we get that same thing, that 1/2 x equals 1.5. Divide both sides by half. And x equals 3 feet. If you noticed right away that, hey, look, it's a 1/2 inch, and every 1/2 inch represents 3 feet, and you knew that, that works. You can see that right away and jump into it. I do sometimes allow that, but it's always nice to see the work that goes with it as well down here. But now we need to answer that final question where it said, what is the area? So to find the area then, you're going to then come down here. The area is length times the width. The length of 36 feet times the width of 3 feet. Grab a calculator, show that work, write on that formula so that way we can always remember length times width. We can remember the formula and how to find the area. So it's 108. Don't forget, it's in real life. So that one's the feet, the big measurement. And because we're talking about area, it's going to be feet squared. Whether you have to measure it, or in this case, you're just reading a blueprint, that's what we're looking at. The big takeaway when we look at this again is the fact that we want to be able to use a scale drawing to find actual distances. And yes, it does say scale factors, and all those things, but when we can find actual distances or find the distance or the measurement on the model or scale drawings, then that allows us to be able to do this guy. And then perhaps sometimes get challenged to be able to recreate scale drawings. That is what we're hoping to do here. Again, just getting focused in up here. We really want to be able to say confidently that we can find that missing measurement, whether in the scale or for the actual.